Okay, so question 6, we have got an oscilloscope with a AC supply connected to it. The voltage increases and decreases continuously. Each box vertically is 5 volts, and we can see that 0 volt line is here, and that is 1 box, 2 box, 3 and 4 boxes to the peak. So that's 4 lots of 5, which is 20 volts. So the maximum voltage in the for this supply is 20 volts. Second part of this question asks you to calculate the frequency of the power supply. So this oscilloscope display shows voltage in the vertical, but in the horizontal it is time. And here within the question it says that each division is 10 milliseconds per division. So every square horizontally contributes to 10 milliseconds. Now, if we look, the cycle, the complete cycle, if you start here, ends here, and then the pattern repeats itself again. So the number of squares for one cycle is 1, 2, 3, and 4 horizontally, and each square is worth 10 milliseconds. So it's 4 squares multiplied by 10 milliseconds. So in total, from there to there, the time for one cycle, or the time period, is 40 milliseconds. Now, once we've got the time period, we know that the time has to be in seconds, so we divide that by 1,000, that's 0.04 seconds. And we know that the frequency is 1 divided by the time period. So put a divide sign here. We can just add a divide sign here. So 1 divided by, so slight mark on there. So that is divide. Just move that. There we go. Okay, so it'll be 1 divided by the time period, 1 divided by 0.04 seconds, and that is 25 hertz. So the formula which we need is frequency is 1 over time period. From the oscilloscope display, we get the time period and then put it into the formula and get the relevant value for the frequency, and the correct unit is hertz, capital H, lowercase z. Okay, so here we have two different types of circuits: a series circuit connected to a 230 volt supply, and a parallel circuit connected to a 230 volt supply. Now 230 volts is going to be distributed to these two lamps. Because they are identical in resistance, they are going to get the same amount of voltage. So it'll be 230 divided by 2, which is 115 volts each. With the parallel circuit, we know that for parallel circuits, the voltage is the same across each light bulb. So if the supply is giving 230 volts, then the lamps will receive the same volts as 230 each. So that's the answer there. And one advantage of lamps connected in parallel instead of series. So lamps in parallel operate independently. What that means, if one stops working, the others are not affected. And the reason is, if something happens here, there's still a path for electricity to flow around here. Or if something happens here, there's still a path for electricity to go around and back and complete the circuit that way as well. If this broke, there is no path for the electricity to complete the circuit, therefore they will all switch off if one breaks in series. Part C, we've got a light bulb holder which only has 2 wires, and the earth wire is missing. Now that's okay, and the reason why that's okay is because cases that are surrounded in plastic, because they are plastic, they do not conduct electricity very well. So plastics are good electrical insulators, and no earth required for plastic cases. Okay. So a fuse can protect a circuit, and something that does the same job as a fuse is a circuit breaker. It's an electromagnetic switch, often located in the fuse box.